Okay, welcome everybody to Robot Builders Night Virtual for Tuesday, October 14th, 2025. And we've got a queue going. We'll have the usual agenda, DPRG news. We've got a queue of folks who've got something to share, and then we'll throw it open to open mic. So DPRG news to share. So I want to share, and Jason, you might be interested in this. We have been started engaging. So at the September monthly meeting, we had a group from UT Dallas Robotics Club and from UT Arlington Robotics Club, and Jason was a part of the kind of like a leader of the UT Arlington group, along with their president and a number of members. And so we've been engaging with the UT Dallas group, and we took a tour. They gave us a tour of their makerspace. This is actually a shot inside their capstone workshop area. We had their president, vice president, a number of the team leads for the different projects they have going. And so that was really enjoyable. And we talked about how the DPRG might be able to engage with UT Dallas Robotics Club. And one of the things that's come out of that, so Mark and I are on their Discord now, and one of the things that's come out of that is I'm scheduled to give a presentation to the Robotics Club on their on ROS and Micro ROS on October 30th. I've also been offering a bit of guidance on how they can help teach their people about ROS, because they really need to learn more about ROS. They've got one person who's somewhat familiar with it, sort of ramping up, but a lot who aren't, and several projects that look like they could use it. One of them is called SRP, which is like a scientific, it's a national university level competition involving a rover that traverses the simulated Mars terrain in Utah and goes out and does scientific experiments and has to avoid boulders and rocks and other things. So that was pretty cool. They've got a bunch of chess bots, which are like robots about yay big, about 6-inch, 8-inch diameter, that are supposed to autonomously move around a big outdoor chess board. I don't think they do at present. They're and then they've got a mini Sumo team, and an underwater robot, which all seem applicable to the autonomous robotics theme that really is what DPRG is all about. The club is very heavily into combat robots, battle bots, and that's really much less something that DPRG is really centered around. So not too much connection there, but there is on the other projects. So Jason, let me just divert here while we're on the subject of DPRG outreach to universities, and I've reached out to you and Aiza, and didn't know if you were interested in having a DPRG visit over there. Mark Reynolds, our VP, and Mike Williamson came over to UTD, and so if you guys were interested in that, I think we could accommodate that before the end of the month.
Sounds good. Yeah, when you had sent that email, I forwarded to them, and everyone was in the middle of a midterm, so they were a little busy. But I'll reach out to them again about it. I think we just need approval from our advisor, because I believe that was also the other blocker, that everybody was in midterms, and at the same time, our advisor needed to give approval. So I'll reach out to them again, see if they can find some time, because of course it's their club at this point. You know, I was president several years ago, so I just need them to kind of like hop onto it. But yeah, that's it. I would definitely be interested, so I'm definitely gonna push for it. I've definitely been pushing for it.
Okay, thank you.
Yeah.
Let's see. Other DPRG news.
Can I ask a real quick question?
Yeah.
Are these clubs would they consider themselves undergraduate level?
The UTA one is definitely undergraduate level. It should be a graduate level. I do believe that many of the, I guess, winning teams are graduate level courses. They're like side research projects. But for the majority of other teams in our level, it's an undergrad project.
Thank you. What about UTD?
I don't have a sense of that, Kareem.
Okay.
Good question, and I that subject never came up.
I can speak on that. The UTD is it's mainly undergraduate.
Jesse. Welcome.
Hi. I believe like we do have a few like graduate students, but I'm pretty sure it's mostly undergraduate.
Thank you.
Okay, thanks. That might explain why ROS isn't super high adoption already.
Yeah. So Jesse is the project manager for the SRP robot, which we looked at, and it was really cool and a big robot, and so I've been trying to encourage him and his team to bring it out to Robo Columbus, but we'll see if that works out. There are some possible impediments.
I'm the project manager for Vex. Pablo is the SRP guy.
Oh, I'm sorry.
No,
My
it's okay.
mistake. Sorry about that. Yes.
It's all right. It's all right.
Okay. Other DPRG news. We will have the monthly meeting on the 4th Saturday, which will be Saturday week, the 25th. We've got so I'll be doing a talk on Git plus GitHub, and then also we'll have a gentleman from the Homebrew Robotics Club in the Silicon Valley who will show us a video he made of an AI, Bing's AI running off the rails in a very dramatic fashion, and he really made a very powerful movie out of that. I think the only other thing I want to make people aware of is that I'm just my personal vacation. I'll be going on vacation from the beginning of November through mid-December, and then mid-January through the end of March. So my personal participation in RBNVs is going to be kind of pretty limited. The club will carry on, and Doug, I'm hoping that you can lead Robo Columbus. We're all set up with Steve for permission to use his place. Robo Columbus for hey Delbert, welcome. Good to see you.
Hello, keep going.
So Robo Columbus is our annual outdoor competition, and Doug as our chief contest officer, as well as secretary and webmaster and spiritual leader of the club and many other roles. will be heading up Robo Columbus, and it is held at one of our members' homes, so we don't put the address out to the public, but or in a public way. But if you want to come, you would be very welcome. By all means, bring a robot or come and watch. The schedule will be on DPRG.org, and just send an email to either secretary@dprg.org, that's Doug, or president@dprg.org, me, or and we'll give you the address where the event will take place on the fourth Saturday of November. Yep, Doug, you're muted.
Robo Columbus in 6 weeks.
Yeah. November 22nd. It's the Saturday before Thanksgiving. All right, I think that's it for DPRG news. So first up, Scott has something to share.
Yeah, I think it's really convenient you're scheduling a vacation time. This date's been set for a long time, so I
think he has to
hate it that you're
schedule
not gonna be able to defend your
non-vacation.
crown.
I think he has to schedule non-vacation time at this point.
Yeah, well, so anyway, but I took a lot of what you did last year very successfully, and I've been working on RTK for belts, and I was doing some field trials this weekend, and one of the parameters now that I get from the GPS radio is the level of accuracy, both the horizontal accuracy and the vertical accuracy, or I guess it'd be the other way around. But I actually saw 1 millimeter of accuracy on Saturday, which really surprised me because I've been getting on average about 10 to 14 millimeter accuracy, which is enough that now I'm having to actually compensate for where the GPS antenna is versus where the bumper is. And it was really strange because on Saturday, the Pixie cam was working great. I could detect an orange blob from 10 feet away. And then I was testing on Sunday before the horrible loss of the Cowboys anyway, but and the Pixie just gave up the ghost. It wouldn't work. So I started looking at, well, let's just eliminate that logic altogether, because one of the things that qualifies, hey, have you hit a cone versus just an obstacle, in my current logic was, am I looking at an orange blob? So I had to change all that logic, but based on the accuracy, just like you proved last year, right? You tell it there's a cone at this location, and by golly, there's a cone. When you get there, there's a cone there. So it was really kind of a shift in logic where before I would, go to this GPS location and look for a cone because it's probably not where you're sitting. Right. And now it's completely different. So I had to kind of flip it around. And I tell you what, it's a problem that I would rather solve than the issues I've had with Pixie cams over the years. So, I still plan to update to, object recognition and put an AI type camera on there, because I'm running the Beagle Bone 64 AI, so it's got plenty of horsepower. And the other thing I found interesting is I was tuning, like my motor dynamics, and because I actually have a PID for my steering, right, so that it's much smoother and it's not real jerky. And even though I had the same motor drive, which is over CAN, so it's the same communications, the dynamic completely changed with the new CPU. Everything was much more responsive, much tighter. So where I would have to dampen something in the past, now I had to increase it, right? So hadn't quite explained why that was, just based on the CPU. But like I said before, it's a good problem to have. So I'm in a good place. Like I said, you showed very clearly last year you don't need a camera. I mean, if your positioning is accurate enough, then the other thing though that I learned from my field testing was, and this was actually weekend before last when it's much hotter. The base station that I have built, I have the GPS and a battery and all that, and the radio in an enclosure, and it got so hot in the sun that the messages started skipping. The internal temperature of the enclosure got so warm that, I guess the electronics, whether it was the transmitter in there or the GPS, I don't really know, but I wrapped a cloth around it to put it in the shade, and the messages, once it started cooling off some, the messages, went back to being consistent. So I built a little doghouse to go around it, like a little shade cabinet for it.
Is it white?
Well, it's actually reflective aluminum. It's diamond plate aluminum, so it's kind of reflective. Because a black plastic enclosure was probably the wrong choice to make for something like that. But that's what I had, so that's what I built it out of. But I also had the aluminum diamond plate, so that's what I built the doghouse out of. So it's a refinement process, right? So I'm trying to iron out those issues before contest time. But I'm pretty happy with where it's at. My other robot turd, though, I turned it on and I was running it, and it couldn't do a damn thing right. So I'm not sure whether it's going to make the grade this year or not, but I'm kind of focused on belts and trying to get, all of that ironed out. And like I said, the RTK stuff is just amazing how accuracy it is, the accuracy on it. And the new Beagle bone board is really paying dividends too. It was a real struggle to get it configured right, because it's not like a Raspberry Pi where there's a lot of community support. No, I've done that before. Someone's configured a Raspberry Pi like that, most likely. Well, if anybody ever configured a Beagle bone AI 64 the way I have, I couldn't find it on the web. So, but to me, that's part of what makes it interesting and kind of exciting and challenging. But it's nice that it's paying off. I'd hate to go through all that work and then have it fall on its face. So, I think the CPU platform now, moving forward, like I said, I still want to do AI and object recognition. I'd like it to be much more cognizant of its environment, other than just let me avoid any obstacle and find a cone. Be able to interact better with this environment. So that's kind of where I'm focusing now, is much more on the obstacle avoidance. And then next year, during the year next year, I'll work on the AI camera. So that's kind of the update there. I hate it that you're not going to be there, Paul, because I love to be the champion. But and I would also propose to the club that we need some sort of crown or trophy or something that has to be passed back and forth. Like, okay, you're the keeper of the, kind of like, the America's Cup or whatever, right? Or the Stanley Cup, where you pass it around.
Texas OU.
It's like, okay, and when you're on the call through the year, you can proudly display it in your camera image. It's like, I am the champion, right?
Robbie, just pass Robbie around.
I love it. The Robo Columbus Cup.
That's right. The Columbus Cup. There you go. That's a good name for it. Although I think there's a yacht contest with that name, but I don't think they'll mind if we steal it, will they?
That's a great idea. I love that.
I like that idea too, Scott. I think that that might, maybe not this year, but in the future.
Well, the next winner gets to buy it for the club.
Oh, ouch! That's an idea, and I'm not real familiar too fond of. I think.
Okay, Scott, I've been out for a while, so I have a few questions. If you may have gone over this stuff. The last time I was talking about RTK, because I'm using a kit from DF Robot that I don't remember. It uses Lrei type of radio communication. And the thing I noticed was, since I'm not using somebody's base station that is available over a phone line or something, wherever that base station decides where it is, even if you let it run for a long time, every time you start it, it may shift your position a bit. Okay, there's a couple of ways that they do it. So one way they do it is the base station just keeps collecting data points until it achieves some sort of spatial, probability, and it says, okay, I'm here. And there's another way that they do it, which I can't remember. But the point is that when it starts up, it's usually that first point that, the first point that does satisfy that condition, that it says where it is. That's not always exactly where it, what I'm trying to say. You can turn it off, let it settle out, and then turn it back on, and you'll find that the base station thinks that it's shifted, a foot, or it's not very much, but it's, a foot or 2 feet around in a circle somewhere. And I was wondering, have you noticed that issue, or are you using one of the available over the phone line type base stations? And then I guess the second question I had, well, that's probably the first one. So let me think of that.
Well, that's obviously the first one, Doug. Well, to kind of expand on what you're talking about, is there's a configuration within the base station, because I'm using the U-Block, what is it, F9, I think they are,
Okay.
that series. I don't know what GPS radio you're using, but your functionalities can be based on whatever that radio is and what kind of functionality it's going to provide to you. But one of the configuration bits that I have is you have what's called a fixed base station mode. So, and there's also the dynamic base station mode, which I think is what you're referring to. And actually, the way I read that, and I didn't get too far into the research, was that the base station then needs a data feed of what the updates are, right? But in the fixed base station mode that I'm in, is really all that gets reported over the radio link is changes in the position, because I've told it this base station's not moving. So any change in your calculated position is a variance in the GPS reporting, right? So that's the correction data that actually gets sent to the rover, because the fixed base station says, oh, well, for whatever reason, the ionosphere had disturbances or whatever, and so I had a shift of 6 feet to the north, let's say, right? So it sends that information to the rover, and so even though its radio thinks, yeah, I see that you're shifting 6 feet over to the left, but instead of actually changing the position, it says, no, that's a correction factor, and I know exactly where I'm at.
Okay.
Right. So that's kind of the way I've got it configured. But like you said, there's dynamic, data sources where that correction data is transmitted, either over the web or, wirelessly or whatever to the rover. So there's different ways you can configure it. So I think that might answer your first question, is that it just gets the correction data, because that's what makes the GPS accuracy limited, right? Because you don't know, as the satellites and the data is shifting, and even like Kareem was talking about the other day, on one of the calls, where you can get reflections from the ground back to the antenna, and the timing with, to triangulate a signal, you have to synchronize it very closely, right? So that's why, there's like an atomic clock stamp in every GPS packet. So there's like a timestamp. So, when you get a reflection from the Earth back up, now the time has changed, right? So there's a variance there, and I don't understand all the, physics of it, but so that's one reason why you only get, without a correction data, you only get, 10 meters of resolution, because you don't know what that uncertainty is.
Yeah. Okay.
So now with RTK, you know what that shift or that uncertainty is, so you can offset it and you can counteract it.
So are you planning to just use RTK? No camera?
Right. Well, I'm going to use RTK, and then I'm going to use my time of flight sensors to actually send. It's very similar to what I do on CanMan, where I have some short range sensors, right? I have 2 on the outside and I have 1 in the center, so I can center up on the cone, right? Because I know at this GPS coordinate, there should be a cone there. There's not going to be an obstacle. So if I see something in my sensor data, it's going to be a cone. That's the assumption. And that's what I was talking about earlier, where you kind of have to flip your thought process around, that it's not that I'm looking for a cone, is that, no, it's here, right?
Mm-hmm.
So if you're not having to look for a cone because you're going to presume it's there, really all you need to do is center up on it and be able to, gently touch it, right? So you still need some sort of resolution, that, because like I was saying before, the 8 inches, or it's about 7.5 inch difference between where my GPS antenna is and where my bumper is, makes a difference. Because what I did in my yard is I put like one of those, sprinkler flags in the yard instead of a cone, just so I knew, okay, this is the GPS coordinate that I'm trying to find.
Yeah.
Right. And it would actually run over the flag about 6 inches to about where the center of the antenna is. So that's when so basically the logic now takes over. So when I get within a few feet of the GPS coordinate, now if I have a sensor hit, because my nominal sensor range is much longer than that, right? It's 6-7 feet is what it's about 500 inches, whatever it is. So I know that I have a hit there. And so I was like, okay, that's a cone. That's the trigger now that tells the logic, this is something you need to go touch and not necessarily avoid. Right. So that
was my other question.
Right. So basically, I kind of flip it around. Instead of avoiding an obstacle, now I want to touch it.
Okay. Last year, you used some TF Mini, I don't know, pros or stuff. Are you still going to use them this year?
Absolutely, man. I'm still impressed with how they work. I noticed you were using them on your indoor robot.
Yeah.
And
they only have a 2-degree cone, you know what I mean?
Yeah.
You find that to be a problem?
Well, my outside sensors are actually on a servo, so I can rotate them around.
So you actually hunt with it?
Yeah.
One I saw didn't have, they were just hardware on aluminum brackets. Yeah. So you've gone from that to a servo based one? Yeah. The whole assembly will pivot up and down in case there's like high grass or something, so I can kind of point them higher. And then the 2 outside ones, because there's 3, the 2 outside ones I can rotate in and out. Mm-hmm. And I've found that about 20 degrees it's 20 degrees in software. It's measuring it is probably not quite that much, but I've basically just dynamically figured out, just by driving it up to cones and rotating it back and forth, that a little bit of an angle either way
gives me a nice field of vision, because when I'm coming up to a cone, and even like say I'm 3 or 4 feet away from it, right? Because as you have the angle and your cones diverge, right, you get dead spots.
Yeah.
Right. But you want to be able to see the cone. You don't want a dead spot, because you want the cone in your sensors, no matter, even when you're several feet away from it.
Yeah.
So I've actually started looking at logic where the sensors kind of focus in, and then as you get closer to it, they may, spread out some. And I even have logic, like when I hit an obstacle, if I'm going straight ahead and I hit an obstacle, I'll kind of rotate the sensor out some, so that, and that's kind of like the hysteresis, if you will, so that when I rotate outside, when the logic says, well, rotate until the sensor's not tripped, now I'm rotating further out. And then once I get there, I'll rotate the sensors in to narrow my vision, and then I can start. And it seems to work much better, because you have this behavior, especially like when you're on a wall, where it's like, oh, there's a wall there, and you go forward, and oh no, there's still a wall there, so you get a little bit smoother option. But that, like I said, that's the kind of thing that I'm starting to work on more now, is that kind of obstacle, a more broad range of obstacle avoidance, not just kind of the here and now, I just don't want to run over this, right? But more like a slam, where I'm mapping, or maybe not quite mapping, but you're using more data to decide how to avoid this obstacle and how to map a path to where you're trying to go.
Okay.
Lawrence raised his hand, but for everyone's information, we don't usually do raised hands in this call. Just feel free to pile on in and speak up and ask any questions.
I was just waiting for a break in the conversation. I figured if I put my hand up, I might get it. Anyways,
Just jump in.
I was just wondering, Scott, have you tried for the RTK? Have you tried on the, whenever you're at the contest area, have you tried, oops, I just lost my earbud. Have you tried like putting a fixed marker in for your RTK, and then just basically taking a GPS reading, and then you just program that back into the base station? So you just put the base station in the same spot and tell it, this is where I am. Because that should give you the same effect. If you could find a surveyor's mark or something and put the base station right over the surveyor's mark, you'd have a real known point. But I think for practical purposes in a contest day, you could just pick a spot, put the base station over it, let it settle down, and then just say, okay, I'm here. And then you measure all your other points after you've got that base station set. And then
that is a good strategy. Otherwise,
but no, that's not how the base station works. It doesn't really matter where the base station actually is, because the base station doesn't transmit its location to the rover. It only transmits correction data.
Right, but so if you tell the base station you're at this position, and then it should transmit the discrepancies from that position.
Right, but that position, as you're calling it, has no relevance. It's just any given position on the globe of the Earth. It says that, okay, based on, because I know I'm not moving. So the base station and the logic in the GPS and the base station knows that any movement that I see in my GPS position is an error, because I know I've been told, and that's what I was saying before, there's a configuration bit that says I'm a fixed location. I am not moving. Now there's other configurations where the base station is moving, and that's a different situation, more probably what you're talking about. But
no, I was talking about a fixed position, but you were saying that you had a problem that every time you turned the base station on, you were getting a different position.
No, that was Doug mentioning that.
Oh, maybe that was Doug. Okay, sorry.
Yeah. And that's kind of irrelevant. I think is really what Scott's saying. It doesn't matter that the base station thinks it's moving around. All that RTK GPS gives you is the distance or the
Is those
difference
movements.
between the base station location and the rover location. So it doesn't
Right,
matter.
but the position of the cones, though, if you turn the base station off and move it somewhere else and then turn it back on again, you're
Doesn't
gonna have
matter.
to remeasure the position of the cones.
No.
No.
The cones are still, because the cone is at a GPS location, right? The base
Right.
station is helping you find that particular GPS location on the planet Earth. It doesn't matter where that
Rob
reference is
brings up a
coming
good
from.
point, though, and I think you guys are talking at cross purposes a little bit, because he's assuming his question or point is assuming that you use the lat long coordinates that you were given at the start of the contest for the position of the cone, and that would change as the base station thought it was moving around, and so what I did, and I think it's really important, is I went out and actually measured the cone position relative to the base station I was using, because if you try and use what the point you're bringing up, Lawrence, if you try and use an absolute lat long, and RTK is giving you just a differential position from the base station, those two can drift relative to each other.
Right. And so I guess what I'm thinking is that you would set the base station up, tell it the lat long of where you put it, and then you would measure the lat long of all the cones relative to that base station.
Right.
And as long as you set the base station in the same position each time and give it the same lat long, all the corrections will be correct to that position.
Well, I'll give you a practical example, right? I set up my base station. This was several weeks ago, right? So I set up my base station at an arbitrary point in my yard. Okay.
Right.
I went out and I put the little sprinkler flags, like I was talking about before, out in the yard. And I took my radio and my computer and I went around the yard and I put it over those flags and I recorded the coordinates of that location. Okay. Since then, over the last few weekends, I have again gone out and placed my base station arbitrarily in my yard, not in the same place. And my robot can still find those pins in the yard with a very high degree of accuracy.
Yeah, we're not talking about much, but I want to say that when I did that, Scott, I found that essentially that measured place that you said you had your flag, that actually shift, probably anywhere about a foot. It would about a foot around, it would move. So, and if I wanted to, I could turn my base station, just leave it in the same place, turn it off, turn it back on, and then let it settle back down. And like I said, it would be about a foot difference. So
that's a scenario. Yeah, I haven't.
It's just but it could be up to a foot or so.
Yeah.
Okay.
Well, the other thing is,
Scott,
it's
you
not
may
like
have Survey In automatically enabled on startup for your base station.
that's one of the config bits is the Survey In. Yeah.
Yeah, if that's already enabled on startup for your base station, then that's going to resolve most of these problems.
What is it now? Say it again.
Survey In.
Survey In is a startup mode that you can enable on your base station.
Okay.
And that's the one, and you can depending on your manufacturer, it can just be like a config thing that you set so that every time you power up your base station, it'll automatically go into Survey In mode for a certain amount of time, and then it'll use that to fix its location.
Okay.
You can also tell it to start up where you have to provide coordinates for it.
Right. And that's what I was talking about. You can feed it data. Right. Is that what you're talking about, Kareem?
Yes.
Some sort of data source. And the other thing with the practical example I just gave, it's not like I'm putting this base station on the other end of my yard, right? It's probably within a 15 to 20 foot radius.
Yeah.
So there, there may not be a lot of variance there for what you're talking about, Doug, or even Lawrence. I really hadn't looked at it that way or tested it that way, because typically what I'll do is I'll set the base station down and just leave it alone, just let it run. And then it just transmits correction data to me. And I actually relay that to the robot. So it doesn't actually relay directly to the rover. I have the base station, I have my telemetry application that I was able to interweave the correction data into that normal comm stream. So I don't have a dedicated radio for the RTK updates.
Yeah, somehow I got to probably go back to the original modular that we used and figure out what configurations changes are possible.
Well, it's very probable that, it's a U-Blot, like one of the F9 series or better, if it's got RTK in it. It's one of the more popular radios.
Yeah.
If you go to Ardu Simple, they sell the RTK kits. But if you dig down into I think it's the support page, they actually have config files that you can load through the U-Center. And it will configure the radio in the survey in, the fixed mode location. And there's a file that you load into the base station, and there's a file they give you for the rover. And you actually just load it into the GPS radio and configure it. I turned some of the messages off just to reduce the serial traffic on the radios, but I really didn't have to mess with it a lot to get it to work. Yeah. Now you do have to, I will caution you though, when you're setting this up, you have to be very patient because these 3D fixes don't come quickly, right? And a lot of times, especially if you're testing it indoors, it won't come at all. So you have to go outside, get a clear view, and then be patient a lot of times. I had the Ardu Simple little modules with the U-Blot F9s on them, and they have LEDs on there that show when the correction data is coming in. Right, they have an RTK message and an RTK fix LED, so you can kind of tell what's going on. And you can see that RTK messages are coming in to the rover radio, but it could be several minutes before it'll actually show that it's a 3D fix.
Yeah.
I know, Paul, you probably saw that too, didn't you?
Oh yeah, yeah. It takes a while.
Yeah. Yep. So yeah, don't get in a hurry. Be patient and but it's kind of frustrating because after you sit there for a while, it's like, okay, now what's going on? And I had mine set up on my pool deck, and of course I was sitting there drinking beer waiting for it to connect. And then, by the time it did, it's like, who gives a damn?
Years ago, I bought a satellite repeater that's meant to go like on the top of your van or something like that to repeat the signal into the van. And it's now the GPSs are good enough; they pretty much work in your house. But as you say, the signal is quite a bit weaker.
Yeah.
So
a lot of times I can get a 3D fix just indoors, especially like if the base station is outside and I've got belts sitting here on the bench. Yeah. A lot of times I'll get a 3D fix. Sometimes I won't. It kind of hit and miss. And when I do, the accuracy reflects that. Because the more satellites you have in range and that you're getting data from, right, the higher level of accuracy that you're going to get.
Yeah. Well, I've been playing around with ArduPilot, and I just plugged the GPS in this afternoon, and I was not expecting it to work on my desk inside. And I looked at the cockpit display and went, "Oh, look, it's got a fix."
Yeah.
So.
Well, you really have to focus on the V accuracy and the H accuracy, because that really, just because you have a fix, the accuracy could be, not what you want it to, because you just don't have that many satellites in range. And I think that's what affects whether you get an RTK fix or not. You know, when you're not outdoors. I other than having to wait a little while, I've never not gotten one outdoors. You know, but yeah, there's been times inside, especially when it's, you know, really overcast or cloudy, or you know, it does seem to affect it even on indoors. But yeah, like I said, this past Saturday I saw 1 millimeter and I couldn't believe it. I was like, really? Of course, you know, it's just a reading on the telemetry display, and you know, I can't show you, well, look, it hit within a millimeter, right? How do you prove that's within a millimeter of that particular GPS location? So, but an interesting story, when I was mapping the pins, you know, a couple of weeks ago, I have a little tripod that I set over the pin, and that particular spot in the yard was kind of on an angle. So, you know, the antenna is probably, I don't know, 5 feet off the ground, maybe. And I kind of stood, you know, because I kind of backed away from it, let it settle some, and I was looking at it, and the thing's kind of off center. And I looked at the GPS coordinate, then I plumbed the tripod up so that it was directly over the cone. And you're not talking about more than 6 inches, you know, and it was a couple of hundred counts on I think it was the latitude or longitude, whichever one it was. You know, I was amazed that, you know, just that long, that far, you know, because I actually had to convert everything, all the Latin lines, to doubles, because originally they were floats and they were getting clipped off.
Yeah.
So I had to go to doubles there, and this is a 64-bit platform, so you'd think a float would be, you know, plenty good enough, but
No.
a double is certainly. I also had trouble because I got tired of actually having to put the coordinates in and then recompile the program, right? So what I've done now too is I have an external file that I can go in and edit, and then when I tell it to run, it'll actually read the file and parse the file up. And I was having trouble with the text to double conversion of the GPS coordinates. So I had to, there's a high precision A to D for double that I had to find a library for. And so I finally got that. That was kind of an ugly bug that was bothering me for a while. So, because I had plenty of accuracy. I was just going to the wrong spot. It's like, what the hell's going on? But anyway,
right.
that's enough for me.
Why don't we move on to Jason, who's got something to share? Oh, Jason's symbol turned into a lock. I don't know what that means. Never seen that before.
Hold on, let me push to a different device.
Hey, Paul, while Jason's working, I noticed that we're getting something from, I think it was LOCK or LOKC, a little icon in the corner. Is somebody, what do they call that? Okay.
No, I don't see that.
Okay, it was there. It was there when Scott was showing his stuff. So Scott, can you do a favor and just share for a second, real quick? There, LOGI. You see it in the corner?
No.
That's just his webcam showing up.
Yeah, it's just the moment.
That's the Logitech.
Sounds like Logitech.
It's just the Logitech logo showing up on his
Got it.
webcam output.
Okay, thanks. I was wondering what it was.
Oh, I see. I see what you're referring to. Yeah. Yeah. Okay, Jason.
Y'all see now?
Yeah.
Cool.
Yeah.
Yeah, so we've so me and Oscar and our other friend Emilio decided to try to compete for the Robo Columbus, as well as, we're also collaborating with the UTA Rover team to just kind of share what we've learned in terms of
Awesome.
ROS. So this is something that, Oscar threw together, I think, over the course of like a couple days. So it's definitely a very, very quick turnaround. You can see it's just a couple of VEX L brackets and like a wooden board. So I was like, all right, whatever. Well, we'll make it happen. So we kind of combined all of the hardware that we already own. So I have like this little depth sensor. We have the LiDAR, GPS. I have an RTK module. I'm missing a cable for it, so I ordered it. So hopefully that comes in sometime soon. Got the motor drivers. I think we only need one, but he bought two. I think they came in a set of two. And the battery. As far as the ROS thing goes, I ended up following some of the ClearPath demos. So we have definitely implemented some of the Nav2 modules, but they're very in the early stages. I've basically just finished the demos. So hopefully at some point this week, if not next week, kind of go towards testing more of it, like, physically on the robot itself, as well as, bring it back to UTAs, be like, hey, look, this is kind of what we threw together. It's basically the exact same setup that you guys have. So it should be pretty straightforward to, I guess, kind of teach you all like where we're at right now. The only difference is I think they have a better 2D, stereo camera. They have a better stereo camera, better battery. But yeah, that's it. So it's pretty simple for now, but hopefully we can, start testing it this or if not next week. But all good. In the simulation runs in Gazebo, everything's looking good so far. Just need to, actually put the physical robot together. And obviously at some point, screw all this down. We just kind of put Velcro on, temporary solution just to see how everything's going to fit. Looks like we might need to expand this out or put a second level on it or put the battery under or some of this stuff under, but should be pretty straightforward.
Hey, Jason, if you don't mind, can you spell your last name? I'll give you a black star on the website.
Sure. So my last name is C-A-B as in boy, R-E-J-O-S.
Okay. I got you for a black star. That's given for robot progress. Okay.
Appreciate it. Can you also put, I guess, Oscar as well on there? Because he's also working on this.
Who? What's his name?
Oscar. He was here earlier. He had to leave. So Oscar and then last name, Alvarez.
You got to spell for me because I can't.
A-L-V-A-R-E-Z.
E-Z?
E-Z, right. And then our third member, who's also, we couldn't come today, is Emilio. So E-M-I-L-I-O. And then last name P-E-N-A. Pena.
P-E-A.
P-E-N-A.
What was the first name again?
Emilio.
Can you spell it?
M-E-I-L-I-O. Emilio.
Okay, got it. All right, thank you.
So,
That's
Jason, what do you plan on using as a chassis?
So this is the chassis. I mean, I know we have like these 4 stumps. We had motors on here earlier,
Okay.
but then we realized that that whenever we had bought the motors, they didn't come with the gearboxes. So the wheels came off, and we're kind of in the process of putting all the gearboxes on. But
Okay.
yeah, this would be the chassis.
So you're gonna have what, 4-wheel independent drive, or?
So I was gonna do tank drive. I think Oscar has the idea we're gonna do 4-wheel independent drive. But I think he's gonna see that tank drive might be the better solution here.
Like
Right.
with a track?
No, tank drive as in like 2 wheels move one way, 2 wheels move the other way.
Differential drive.
Yeah, differential
Here,
drive.
essentially.
Yeah. Skid steer.
Yeah, skid steer.
Okay. Interesting.
Oh. And do you have a GPS of some kind?
Yeah, we have a GPS that's located here. I need to create a post to put the LiDAR and the GPS on. They're kind of controlled by this Columbus USB to NEMA connection. I also have a M.2 RTK module. I am just missing a cable for it, so I just need to reorder that at some point in the near future. That's it.
Cool.
I like your safety button.
Appreciate it. Yeah, it's very big.
Industrial.
Do you know about RTK to go, Jason?
Yes, I am aware. My only question is for RTK. At least whenever I've used it in the past, I've had to route it through a network. So at least in industrial applications, we just route it through like a SIM card and we just go through the cell tower. What options, I guess, do we have while we're out there? Is it just, can we just connect our phones to it, or I'm not sure what people typically do.
Well, I don't know. So I think different people are going different directions. Last year, I used my phone to connect to the network and get the and get to RTK to go. And then the guy that hosts the competition actually has an RTK to go base station at his house. So it's actually right there. You don't have a distance issue. I think some of the other members like Doug and some others are planning to bring their own base station. I think maybe Scott and set it up somewhere in the area. So different approaches, but then they have to provide their own wireless connection between the base station and the rover.
Right, and I remember Oscar had bought a router thinking that there was going to be power on site, but I doubt there will be power on site, right? It's just a field that we're all driving out to.
No, there's a pits. The robot pits is actually in our host's back porch. So he's got outlets in his back patio. You might want to bring an outlet strip, but yeah, there's typically power in the pit area. Now, obviously, the course area is quite big, 100 yards by 100 yards, give or take, and there's no power out there. But in the pit area, yeah, there is power.
But
in the pit area, is it
table
possible
and
to have
chairs.
Ethernet? Okay, bring your own table chairs. That's fine. Is there like an Ethernet connection, or can we like access their Wi-Fi to maybe just jump their Wi-Fi forward?
Wi-Fi available.
Okay.
Yeah, he has a guest. He has a guest set up now.
Okay.
I don't know what coverage on the yard he has, but he does have a guest set up, so that like on the porch, there's Wi-Fi is no problem.
I
Right.
would expect Wi-Fi on his network to work all the way throughout the entire course, though.
Yeah.
You'd probably need a hotspot for your robot.
Yeah.
Right. Yeah, I figured that we would either do a hotspot for the robot or set up the router to balance or like to repeat the forward the Wi-Fi network that they have, and we could just provide our own antenna to like just blast the signal out there. But I don't know, we might just connect our phones since that's like 3 times easier. But we'll see. Yeah.
Phones are easier.
Yeah. All right, thank you.
Very cool, Jason. This is exciting. Getting some new robots and new people competing. That's wonderful. All right. Next up, Matthew.
Hey, how are y'all?
Good.
All right, so this is my first time joining this meeting, so I'll just give a brief background.
Welcome.
I'm based here in Dallas. I work at Texas Instruments on the MST product line. So, if you've used the microcontrollers, you may have crossed paths with those. I have been working on an interesting project here for a few months now. I will go ahead and share my screen, but have y'all heard of the micro mouse competition?
Yes.
Oh, yeah.
Yes.
This is one in Fort Worth. But I'm
You're not
sure.
gonna
I'm
say you
trying
got one that's
to-
competitive with the Japanese, are you?
No.
Maybe.
So actually, the concept. Well, so this first one that I'm doing, it's just to get on my foot in the door. Okay.
Right.
The concept of the competition is to search the maze, and then they move very, very fast. I have narrowed the scope of mine to make it doable, for this first attempt. So, the one on the screen here, this one has a vacuum fan that sucks it down to the ground. It's got 4 wheels. It's very, very fast. Mine doesn't have that one right now by design because I wanted to keep it, doable, right? So I just have 2 wheels. It's powered by a lot of the same hardware that the competitive ones are doing, but it's just designed to get the foot in the door. I've been spending a ton of time working on the pathfinding algorithm. I actually just got that working today.
Are you
So
gonna have suction?
I'm able. This one does not have suction.
Okay.
The Mark III will have suction though. But basically, the concept here is that this algorithm is going to search the maze, and then it's going to generate a list of instructions that the robot is going to follow. And we've been talking, a lot about GPS, but for this type of competition, the maze is only about 10 feet by 10 feet. So there goes most of your accuracy, or there goes most of your accuracy right there. So instead, these are primarily using encoders and characteristics of the maze to navigate. So you can move like 10 cells forward and you know exactly how far you've gone, unless you start to have wheel slippage and other things like that. But since you know how large the maze is, you know how large each cell is, you can use characteristics of that to update your map as you go. So if, for example, you're going along and there's like 2 squares and then there's a gap on the right side of the path, you can use that gap to recalibrate your map. So it's a very dead reckoning style of navigation. So the real challenge here is control and making sure that you don't crash into the walls. So this first attempt is really to make sure that I understand the composition, test out the software, test out the navigation, and ultimately, maybe in the following competition, this one's in March, but maybe next March, I'll be able to actually design one that's going to be a lot faster.
The course is always on a regular grid, right? So whichever walls are in place, you're going to know what your distance is from one cell to the next.
Yeah. So in this example here, each grid is going to be, I think it's 18 centimeters by 18 centimeters.
Mm-hmm.
So one common strategy that people do is, let's say you're going down a path and you run into a dead end. Well, that's a dead end. So what you can do is back the robot up until it touches the wall. So then you are at a known cell and you put yourself into a known position inside that cell. So that will allow you to recalibrate your encoders. And you will most certainly always have some slip, especially on turns, because these are using tank steering. And the CG or the center of rotation and that is not going to be at the exact center of each wheel. So there is going to be some slippage, and you have to be able to compensate for that. Oh, actually, one more point that I forgot to bring up. During turns, most of the robots are using the IMUs, and so they have gyroscopes that they use to measure how far and how fast you're turning. And I do have that. That is this a very small component here on the left. So that is used during turns. Not too many people use them for positioning, since they tend to accumulate the errors very quickly due to the integration. But it's going to be a combination of encoders and gyroscopes.
Matthew, why do you need to back? Is it reasonable within the competition to use a LiDAR to determine where you are relative to the walls, so that you can position, so that you don't have to back up to where you're touching a wall to know that where you are exactly?
So that's a good question. I explored. I'm using LiDAR and time of flight, and I was looking at one of the ST micro time of flight sensors, and the best update rate is about 100 hertz, I believe. So these robots can travel much faster than 1 meter per second. So you're going to be losing, millimeters of accuracy just due to the update rate itself. And as far as why we don't use the LiDAR or the LiDAR sensors, this robot here that I'm drawing in KiCad, it's only about 7 centimeters from wheel to wheel. So that's just under 3 inches. And I haven't seen a LiDAR module that would be small enough. And even if I could, I doubt that the update rate would be fast enough for the high-speed maneuvers.
Wow.
I'm using some photodiodes as my distance sensors. I've actually already tested it out. I made a test board that has the op amp and the sensors on it. And I discovered that I was using the wrong resistor on my transimpedance amplifier. So I had to fix that, but I think we're good to go now. I have enough range to measure the distance of the walls. So, yeah, I've been spending most of my time recently working on the software. The software it's been fun. It's actually the largest project in C that I've attempted. I've got a whole ton of functions here and stuff, but I've just started working on the actual hardware implementation. I'm waiting on my motors to arrive. Yeah, this project has a lot of components. It's been a learning experience.
You said that it had a suction, like a.
No,
What does
he's
that
going to
mean?
do that for the next one. A lot of them have
Oh.
fans to increase their grip, right? So just like illegal F1 cars do, sort of, active fans.
Yeah, that's correct. I chose not to put the fan on this one. I'm trying to find a clear picture of one that does. This is one of the Japanese ones, and those tend to be the most competitive. Actually, this one's from Taiwan, I believe. This red circle here is a fan that is used to actually suck the wheels down to the ground. So they had tremendous amounts of traction, and I think they can take turns like over 6G. So it's very impressive.
Wow.
That's amazing. So small. That's awesome.
Yeah.
Wow.
So for motor control, do you use like a PID loop, or is it more or less open loop and you're just hitting it
So
with...
there is a PID loop. I haven't coded that in yet. I'm using 2 brushed motors, and the motor driver here on the left is from TI. I just feed in a PWM signal to control the motor behavior. So the PID loop is going to adjust those. I'm still working through some of the control logic here. I'm going to manage steering and keeping it centered in the cell. I've got a whole notebook here that's filled with flow charts and ideas I'm going to be implementing in code over the next few weeks. But I'm trying to race the motors, right? I think they're going to be coming in November. I want to have as much of the code done as I can prior to them arriving, so I can just plug and play.
They brushless?
These are brushed.
Brushed. Okay.
I was thinking about doing a brushless, and maybe the second one I might, or maybe the second rev I might have brushless. But that adds a bunch of extra control considerations. You got to get a brushless motor driver, and those are larger. I can do it, but takes more board space, and I'm not sure it's totally necessary right now. You can get super small brushless motors. That would be very nice, but it's something I'll explore in the future.
TI has some really nice brushless motor controllers.
I was looking at those. Yeah, I know some guys that work on them. Actually, Yeah, one of the guys that I work with now actually just came from the motor driver team. So he's got some knowledge that would probably be good to have.
Looks like a
but
cool project.
Despite working for TI, I'm using an ST microcontroller.
Shh, we won't tell anyone.
Yeah.
That's blasphemy.
But yeah.
I don't know. Every
Well,
time I've had to use a TI micro, I regretted it. Not one of my
I feel you.
favorites. And Code
Yeah,
Composer
they all have
Studio,
their
you can
pros
keep
and
it.
cons. Yeah, so actually, I dislike the Cube IDE quite a bit. So today I was looking into just programming it, bare metal, just building my own ARM toolchain, and I'm thinking about doing that because I have a project structure that I like. I've got my include, my sources, and eventually I'm gonna have a whole separate section that has the the hardware interfaces. And my experience with the ST Cube IDE is it likes to vaporize your code every now and then, especially if you put things in the main loop. That that kind of sucks. That's one thing that the TI tools do better, and not vaporizing your code. But
you can go back in the DPRG archives. I think it was about this time last year. I gave a demonstration of a Visual Studios plugin that I use quite a bit for development, both on STs and all kinds of ARM parts. I find it very useful. It's called Visual GDB.
Is this the one right here?
It's a purchase product. There's some other ones too, I think, that kind of do similar functions. I'm not that familiar with them, but so you can bring that video up, and I kind of walk through, setting up a project and using a JTAG, and that sort of thing. So that kind of sounds like something that you're looking for. And that's one of the options out there. It's reasonably priced. I mean, you do have to buy it, but it's reasonably priced.
Yeah. I find it usually pays to.
And you can use,
good tools.
Visual Studios Code or Visual Code or Visual Studios Community. It'll plug into any of those. And it also does, you can do Python in it. You can do, it's basically a CMake wrapper kind of setup for embedded projects.
Yeah, I'll definitely take a look at that. I'm definitely interested in getting out of the vendor IDEs if possible.
Yeah, and to me, MX Cube was the most frustrating thing to work in because, like you said, if you don't put your code in the right place and you regenerate initialization code, poof, it all goes away. I agree with you. The way it's structured is not the way I like to structure projects. I also think their drivers their serial driver in particular, I really despise. Especially the interrupt driven part of it. But that's also not something you'll get away from with Visual Studios, right? It's going to use those same platform drivers, but you won't have the same structure. The problem is you got to go through and figure out all the register bits if you're going to set up a peripheral or something, and that's one thing where what is it? Not the cube, but the configurator. I forget what they call it. That's really the only thing that thing's good for is configuring the peripherals.
Absolutely.
Other than that, it's I found it very cumbersome to work in.
Yeah. Once you pass the config phase, it's lots of dead weight. I mean, if you look at the code, there's tons of these
Yeah.
on these blocks here. And if you don't put your code in here, it's going to vaporize it. So it's it's a pain to work in. So I'm trying to avoid that at all costs.
Well, the other thing that I really dislike about it is the way it has a single interrupt vector file, right?
Mhm.
The IT file. You know, I don't really care for that structure either myself.
Mm-hmm. Yeah. So yeah, I'll definitely take a look at that talk you gave. Was that last week or just?
No, it was
weeks ago?
about a year ago, I think.
Yeah, so
Oh,
Matthew,
okay.
I just pasted in the chat a link to the page that's got the video for Scott's presentation. It was at the September 28th, 2024 monthly meeting, and you'll find the video of his presentation and his slide decks and other related resources if you go down to September 28th on that DPRG page.
Okay, cool. Yeah, I'll take a look at that.
But this looks like a cool project, Matthew.
Yeah.
I'm like, wow, that's pretty intense. That micro mouse competition.
Yeah,
I mean,
I hadn't heard of that before. I mean, that seems like a very competitive environment. Some of the speed those things are going. Jeez.
yeah.
Yeah. Yeah, the competition is in March. It's going to be in San Antonio this year. So I'm hoping to compete in that one. And assuming I get that one done, I have all kinds of new plans for the third rev of this bot. I'm going to go all out on it.
Do you have a contest arena like set up at your place?
No, I'm going to have to build that one too. I'm going to build like, maybe a quarter size, so just like one quadrant of it. I don't have room here to put the whole thing. So yeah, but my code will scale to any maze size within reason, so it shouldn't be a problem operating on larger mazes. I can do a lot of simulation. I can load in different mazes and then test the code without actually having to have the robot. So that's very useful. This would be very difficult to debug on a robot. That's for sure.
Very cool. Thanks for sharing that. All right, Doug, you had a question. Where'd Doug go? Doug, you're muted if you're trying to talk.
Okay, it's my turn.
Yep.
Okay, I wanted to just let people be aware of something that I thought was kind of interesting. I've been kind of interested in desktop CNCs just to see where that market was going to go, and let me see, share this. So I don't think this will work. Do you guys see anything? Okay, yeah. All right, so this has kind of been the market, the market leader currently, and the Calvera has a more expensive model that's got some really nice features, but this one actually seems to be more competitively priced and has really good reviews and whatnot. So this has sort of been the benchmark, new people trying to bring new products to bear. So if I were to say that, I would say this would be equivalent to the Bamboo Lab enclosed things, and they usually have among them they usually have a rotary fixture that you can buy, and you can buy a laser module for them, and you can do all sorts. But the one is the actual CNC router, and so I noticed this showed up Well, let's see if I can fix this. Present something else.
It's supposed to do soft metals.
Yes. That's one of the things. And so this is the new, this is, you can see, is a Kickstarter that's popped out. And let's see if I can get to it. Okay. The biggest problem I have with these units is the spindles seem pretty anemic. They're only usually, I think on this one it's 250, and on the Calvera Air it's 200 watts. And you know, on mine I'm throwing around 750 watts. So I'm just a little, you know, my experience with these, you know, 200-watt machines has been, yeah, they cut aluminum, but they do it really slow. But like I say, if you go out on YouTube and look at the reviews of these, they're really something else. I mean, they are very accurate, and so maybe with what I'm doing is more brute force, you know, with the higher wattage, and what they're doing is higher precision. You know, this thing claims, what is it, 0.02 millimeter. Okay, you know, let's do that. I'm sure that's specsmanship, but you know what I'm saying. At least they have two models here. They have a D1 and a D1S. The D1 is the cheaper of the two, and it's actually still in super early bird, and so it's about $421. Now, what the biggest difference between them is one of them, I think, uses ball. What do they call it? The rod has balls in it. You know what I'm talking about?
Recirculating ball screws.
Yes, thank you, Ray. They use that where I think the other one doesn't. I think it just uses what do they call it? Where they put a nut in there and they expand it. So
Anti-backlash.
Yes, thank you. And so there's a little difference. The D1 is on early bird, so they've sold all the super early bird ones off. So that right off tells you that the potential audience is really looking at the upgraded machine. But it's still, you know, it's only $471. Now let's, you know, the Air, I think you remember, it was like $2,500. So this is if this is any good, this is you know, they're really whacking the market. This is going to be something to look at. So anyway, I just thought I would throw this out. I mean, it's an interest of mine. Do I need another CNC router? No, I don't, because I've got more projects than I can do on the one I've got. And my problem is software, finding a good software fix for it. But anyway, so I thought if anybody else, the nice advantage of these is that they're so compact and easy. You can put them on your desk, and they won't cover your whole room with little sparkly bits of aluminum. So anyway, something to think about. That's really the only thing I wanted to do, and also mention that, you know, if you're preparing your robot for Robo Columbus, you got 6 weeks, so you need to be out there testing it. And I'm hoping to show something next week on my robot. I've had a few hacks, but I think I've worked through them, and we'll see how that goes. Okay, that's all I had, Paul.
Okay, thanks, Doug. All right.
Well,
I think
Doug had an hack. I had an shit the other day. I slammed into a tree and busted the whole bumper assembly belch. I had to replace the whole thing.
Yeah, that's the problem.
That was more than heck.
Yeah, since you're trying to keep that tennis ball on top of the cone, you've got to make your bumper really kind of, like engage really at a light, kind of a light touch. And yet, when you hit something hard, oh man, it's just, yeah. Okay.
Well, it actually
heart goes
cratered
out to you,
the
Scott.
button.
Cool. Thanks, Doug. Okay, we've reached the open mic section, and I wanted to share two things before I throw it open. Chris Netta had asked last week, whatever happened to David Anderson? And I said I'd touch base with him. So he replied, he said he still follows the DPRG online and occasionally watches the videos. And he said he put away his roboty things at the beginning of the pandemic and has been occupied with other things since, mostly making music for the dance department there at SMU and elsewhere. Much fun, but time consuming. And he said the quarterly luncheons sound like a worthy effort and he might well join in and say hey to everyone and thank you for the invite and kind words. So anyway, that's a word from David Anderson. And then the other thing was for any of the folks on the call who are somewhat new to this forum and maybe aren't connected with the DPRG, send an email to me, president@dprg.org will reach me, and I'll send you back a link to the Connect with DPRG document that I maintain that lists our the events that we hold and the forums, communication forums that we have, like Airbnb and email and Discord and so forth. And basically, it'll help you get like plugged into what's going on, how to connect with the club, and what we do, and orient you around the IT services that we maintain. Okay, so with that, who's got something they want to share on open mic?
Well, my robot, I took it outside. I turned on the GPS and tried to fuse it in and get it to control the odometry or the odom frame. And things are moving on the plot, but something's wrong because it seems like my XY coordinate, Cartesian coordinates of the map and the GPS coordinates are not correct. And so they're fighting each other. Yeah, so I got to debug some stuff. So somehow I got it to work with incorrect coordinates or something. But when I put GPS in, that's like an absolute coordinates. Like, oh crap, my made up stuff is broken, is now breaking everything. So, but my compass works really good. I was surprised. I was really happy.
So it's a
so I got a good compass. The GPS is GPS. It's a lot worse than I thought it would be. I think I need one of those those plates to try to stabilize it.
Yeah.
Quote ground plane, and but otherwise, like the IMU, I guess is okay. Like I said, I think all I'm using as IMU is the compass and the wheel odometry, but the wheel odometry is really bad. So it just doesn't hold together on terrain outside or even inside, but because I'm not really doing wheel odometry, I'm just doing shaft odometry or something and just guessing what the angle of the steering wheel is. So that's what I'm doing. I'm just venting because I couldn't get it. It just wasn't working. It wasn't working. It was doing stuff, but it wasn't doing what it's supposed to do. Yeah.
Hey, Mike, you were talking about I know you're using a 1/8 model, RC model as a basis.
1/6, but yeah.
And I know you got, you have your steering, You mentioned that your steering was, you were having trouble with it. In actuality, even though you can control the angle of your steering very, you know, with your servo, it probably isn't any, doing it bang bang is probably just as good, because you're usually swinging it from one end to the other. You're not really doing fine adjustments. I'm just saying it's the ability to be able to have accurate steering is not as impressive as you would first think, you know, as opposed to just bang bang. So
but when you sort of integrate the steering with the integrating the wheel encoders to get you integrate the steering to get your angle odometry with the wheel encoders, it's just not there. I mean, it knows it's turning right, but it doesn't know how much or anything.
right.
So I need to figure out how to use the IMU a little better. Maybe put more emphasis on IMU and less on encoders.
Yeah, but I mean, I'm assuming you have a steering PID, and that's what you're using to set the steering.
No, I'm just open loop because I don't have any feedback on the steering. So it's just a servo motor and say move to this angle. And
Gotcha.
it's supposed to be that angle. Yeah.
No, you set it at an angle. That's why I'm saying, you know, just setting it. Otherwise, instead of trying to be really,
but it works. It works pretty good when I got a cone in my sight. It says, here the cone's in the sight. Now use the steering to center the cone. The fine resolution works really well because it can go smoothly to where it's supposed to go, but it's mostly at a hard angle until it gets closer to the center. Then it lightens up and goes straight to the cone. So, but I just got to get the GPS work so it can find the cones.
Yeah.
And you're just using regular GPS, right? Not
Right. Yeah. In fact, I put a coordinate that said go 10 meters forward, and it was running all over the yard. It was just, it's like it was chasing its tail or something. Yeah. So I got a couple things I got to work on, like I got a really tight tolerance on when I've approached the goal. I think I need to make it a lot looser so that when it gets just close, I mean, vaguely close, not close, but vaguely close, then stop and then start using the camera for a cone. Because I think it just chases its tail because the GPS keeps moving around and it's like, oh, I'm not there anymore. I got to turn and move. And so it just wanders around with the GPS or something. And oh well, I got my work cut out. So,
Mike, have you tested the, I'm assuming you're using those time of flight sensors, the 8x8 arrays for the ones that were made more for outdoors. Have you done any testing on those?
Nothing outdoors. I mean, they're there, and the robot was avoiding obstacles when it was running around with its head cut off like a chicken, but it never ran into anything.
Yeah,
okay. But probably more in the LiDAR, but those are more for obstacle detection down low on the ground, like boulders that you don't want to run over that the LiDAR can't see.
You mean things like sewer covers?
And I think.
Oh yeah.
I think I use them for the final pull in to say I'm there. So yeah.
Okay. And your LiDAR seems to be working outside fairly well.
Yeah. Well, one thing I do notice with the LiDAR is the terrain. It's not even very rough here, but you can see. Wish I could play a script, but you can see that it sees the ground sometimes, and then it becomes an obstacle.
Mm-hmm.
And then when it straightens out, the obstacle goes away, and so it sort of doesn't go. So it doesn't think it can go that way until the obstacle goes away, and then it can go that way. So it's Yeah, I'm not sure what to do about that, but I guess I need to loosen up the range on it. I need to say, instead of like looking out 10 meters, look out just 3 or 4 meters. And that would probably keep it from being so bad and seeing the ground slope as an obstacle.
So you tested it against like clumps of grass and saplings and trees and bales of hay.
I mean, there was like a fence, and it avoided the fence.
Okay.
You need to test it against horse apples.
Horse apples, right? Yep.
Yeah, I think my sensors would see, the lower sensors would see horse apples. But even like if it's like how big, like 100, like 80 millimeter, 80, yeah, 8 centimeters, I'll just drive over that. So, 'cause I don't want it to see clutter on the ground as obstacles. So I set the range so it doesn't, if it's below, I think right now it's at 100 millimeters. And if it's below that, then it doesn't consider an obstacle because it can just drive over it. My car is big enough. Yeah, it can do it. And otherwise, I didn't want it to see weird stuff on the ground as an obstacle. So
yeah.
But the LiDAR is like what is it, like 300 millimeters or off of the ground. So it really can't see anything very low.
Yeah, it's pretty high.
Yeah. I mean, if you look at it,
300 millimeters. So that's like a foot, right?
Yeah, foot off the ground.
Yeah.
Huh. My computer went black. Oh, my screen went black. Why'd it go black? Oh, there it is back. Okay.
Yeah, you're sort of frozen. I think your network might be hanging up a bit.
Oh, it's even frozen on my side. Can you hear me?
Yeah, we can hear you, but your video is frozen with you sort of like standing.
Oh, it is. You see my butt? Yeah. That's what I see. Huh. Oh well, I'm gonna stop. But it's about a foot high off the ground because the wheels are huge. Like see if I go over here. The wheels are like 7 inches diameter, and then the chassis goes up above that. So it's a tall beast. Yeah. Oh, wonder what happened to my camera.
There you go.
Am I on or off?
You.
Oh, I'm back.
You're back.
Yeah, I'll pick up the robot and bring it over. So plugged in the power right now, but
that is a big robot.
So you can see the LiDAR is way up there. Oh, I've got to get it all in the frame. So yeah, it's way.
Yeah, these
up.
bots are larger than I expected.
And I believe I have all the sensors at the height they're going to be, and it's not using blue tape anymore. It's I made little 3D printed mounts for everything. So I think everything's in the position it's going to be. So I'm going to have to transfer everything over to the final platform and put it inside the cabin. But I'm not going to do that until the last minute. Or maybe in 3 weeks. Yeah.
Yeah, Matthew, the outdoor robots need to be kind of large because the terrain is kind of rough. But we have smaller robots for the indoor competitions.
Yeah, I was excited about that micro mouse robot.
That makes sense.
That thing's so small. I want to make a small
me
robot,
too.
but I was thinking of the mini Sumo.
I would love to do mini sumo. So if y'all do that, I will definitely be partaking.
Yeah. But we
We
do it.
actually had a mini sumo competition at the last Roborama in April, and basically what we do is if there are people with robots that want to compete in a particular competition, then yeah, we'll run it. And Scott had about 3 robots and 3 mini sumo robots, and who else had one?
Ron Grant had one, and
That's right.
Mark had
what's
one.
his name? Mark, yeah.
Yeah.
UTD has a whole set of them. UTD does that a lot.
Yeah, right. So Jesse, if you want to give a heads up to your mini sumo people that will probably, if there's interest in running it again, we'll probably run mini sumo again at Roborama in April next year. April, May. I think it's May we usually hold it. Yeah.
Yeah, all right. I will. I'll text the project manager for Sumo.
Yeah. Awesome.
Because
Thanks.
I'll probably buy a little kit just to get into it, but I really want to build one from scratch. That sounds very challenging. Yeah.
It's a different set of challenges than what we're used to as far as navigation and not so much sensors, but it's an interesting set of problems, because now you're not really trying to achieve a particular goal, right? You're trying to survive. And to me, that's one of the attractions to sumo, mini sumo, or whatever level you're on, is kind of the randomness of it, and the interaction between the 2 robots. It's always entertaining.
Mm-hmm. And you don't have to worry. You don't have to worry about running over horse apples and stuff.
Right. Yeah. Or cleaning mud out of your computer, or between your wheels, or or walking halfway across the yard and picking up a 30-pound robot and carrying it back over to the workbench. Because you know what that's like, right, Mike?
I carry this thing around quite a bit because I live in a 3-story place, so I go up and down stairs a lot with it. It's no fun.
So can we make that official, Paul? We're going to include mini sumo in the contest in the spring. Is that an official decision?
Well, I defer to our contest master, Doug.
Okay.
But our policy has been, I think always been, and I don't see any reason why it would change, is that if people want to run a particular competition, then hey, we'll put it on.
Yeah. So if we have two sumos, then we got a competition. Yeah.
Two contestants, 2 different people.
Two contestants. Yeah.
Best 2 out of 3.
Okay.
Hey, Paul, when did you say the Roborama thing for Sumo was?
May. May 2026 will be the next one.
Okay.
So
Awesome.
we do the outdoor contest Robo Columbus in November, and then the indoor contests. We have numerous indoor contests. Like going around a square and going out to a target zone and back, and as well as collecting 6 cans and taking them to a goal, and mini sumo, and a variety of different things.
So that's in May usually, right?
But
you can look at the website under competitions, and there should be Roborama 2024, and it can tell you about what competitions were ran last year, and also has a link to the results and stuff.
I've got something to
Yeah,
share.
so if it's in May, that gives me about 2 months after the Micro Mouse competition. So that should be some time to get it spun up.
I've got something to share that may be of interest to this group. Let's see, is this? Yeah. So I got an email or communication through the DPRG Facebook page from a guy who's been around in the club for a long time, sort of like a part of the community, Vincent Lrei, and you can read it here. But basically, he's offering the club a wheelchair with 24-volt, 750-watt motors that will travel 6 miles an hour and push a car to anyone who might want to make a robot out of it.
I'd be interested.
Maybe that could be a club project for next year when we do the annual meeting. Paul.
Uh-huh.
So is he looking for payment for it then? Since I don't see an actual business proposition other than he gives
I
the.
don't see any business proposition other than he offers the club a wheelchair if the club wants to make a robot out of it. That's the only thing I can see.
Yeah. Okay. Well, if you got no other takers, I'm interested.
Do you know Vincent Lrei?
Nope.
Okay, I don't either. Okay, well, I can communicate back to him saying, Ray's interested. We could bring it up at the January meeting, like Doug suggested, to see if there's interest in doing a club project on it. But
sure.
I mean, I always thought it'd be fun to get one of those wheelchair assemblies, and because they have powerful motors, and that'd be kind of fun. But I think they'd be heavy.
Yeah, the especially if they have like the 12-inch wheels, those are, you get a lot better ground clearance with a wheel that size versus the, like an 8-inch or something, because the kind of, part of the gearbox hangs down and eats up a little bit of the ground clearance. So with a smaller wheel.
Oh.
But
okay. All right. Well, I got something to go back to him with. So
okay.
Thanks for that. All right. The other open mic things. If not,
I got a small update.
Yeah,
just a 20-second update. Reach out to Paul. Thank you for the help. I managed to get get a Docker working between my Raspberry Pi and my computer. And so Paul provided me with a Docker file and a script, a bash script for a bash RC file. from his posting on GitHub, and I had to modify it to run on Raspbian a little bit on Bookworm, but I did manage to get it up and communicating and got my LiDAR sending messages across to the computer to be able to monitor, and it's good. I can communicate back and forth both ways. So it was, I was very thankful for Paul to help me out, and thanks everybody for your input last week.
Awesome, Pat. And on the subject of Dockers, I ran across an interesting thing. So as part of the UTD Discord conversations that were going on, someone posted some links to Articulated Robotics. They have a whole bunch of ROS tutorials, and I've just pasted in the chat a tutorial on div containers for Docker. And I watched the video, and I sort of understand it, but sort of not. So I need to rewatch it and try it. But what I got out of the video is that there's a extension for VS Code that they call a dev containers extension. And as far as I can tell, it is sort of like, you know how you can get VS Code to SSH into a Raspberry Pi, and you can edit files, code files on the Raspberry Pi and build them on the Raspberry Pi. Well, it's sort of like that for Docker containers, and so somehow it like hooks in to the Docker containers and mounts your source code from like your host computer, and all kinds of magical stuff that I was like, wow, that I didn't really understand it all that well, but I'm going to dig into it because it looked pretty magical. So, Pat, you might take a look at that video because
hopefully that's some pretty good automated stuff, because how we do that in the past is we would make a very, very special Docker container, right, with your config file there, and mount something that's local to wherever the host is, so that every time you reboot the Docker container, you don't lose your files. And then you open up the host session, and then you use your Visual Studio from your Windows device to mount over the SSH into your Raspberry Pi or whatever is running your Docker container, and from there you SSH into your dev container, and then you can go about, and it pushes that stuff all along. So hopefully they made that better. I mean, that's what I was doing the last time I touched it, which was a little while ago. You know, hopefully they're doing way better having it. That's probably effectively what they're doing, but if they got it where it's like automatic, where you don't have to mess with that and it does all the right things for you, that'd be amazing. That'd be amazing.
Well, you know way more about this already than
I don't. Maybe I'm just regurgitating my nightmare, Paul. You know, I don't know if I don't know that I know very much at all some days.
Oh,
I do. I want to get in line somewhere, by the way, whenever we're talking.
Feel free to jump in.
No, I thought Pat had
I have a quick thing for Ray. The LiDAR outside, so I can demonstrate this bag file. Let's see, so let me pull it up, and I'll just do a quickie. Okay, so select the Foxglove. Yeah, so you can see that the if I bring it back to the beginning here, you'll see some lines come up over here, and that's sort of the ground being detected.
Oh, wow, that's awesome.
Yeah.
So that's your truck navigating around your backyard.
Yeah, and And so it's just seeing the ground clutter as some obstacles here, but they go away because it's not persistent. But like this is a hard fence and a hard fence and hard fences and stuff. But so that's sort of my. And then you can see the odometry slipping. Everything is spinning around. It doesn't know exactly where it's at. So
now it's reversed. So it went forward and now it's reversing back along its course.
It's just trying to go the waypoints, but it's not doing a very good job.
but I mean,
because the odometry is slipping.
It's going backwards. It's like going forwards and backwards, like a Ackerman steered vehicle has to.
Yeah. I don't like it going backwards, but I got to figure out how to put more penalty on it so it doesn't go backwards unless it really has to. So that's my show and tell. So on that, and then you can see the GPS sort of shows the tracks. Like that's, yeah. So my house is this one on the corner here, and this is a big open area.
Cool.
So, and then my battery gauge, I can see how much battery is left. So, yeah. So I just pulled out a couple things to look at.
Oh, that's cool.
I didn't have my compass enabled yet, so this window doesn't have anything. Okay, that's my show and tell.
That's neat, Mike.
Thank you.
How large is the course that y'all run these on?
It's about 100 yards between each cone. So from the start to the first cone, from the first cone to the second cone, you can see the first cone. That's part of the rules is you can head directly to the first cone from the start. So, it's kind of like the first cone is an easier target. Still about 100 yards. So over roughish terrain. And then the second cone is not visible from the first cone, so your robot has to be able to do waypoints or something or other to get between to the second cone, and then back to the near the finish cone is near the start, and that's probably 150 yards.
Okay, cool.
Yeah, I was trying to do waypoints like 10 or 20 yards apart using GPS, and the GPS accuracy was about 10 yards. So, so I got to spread them out a little bit.
That doesn't sound right, Mike, because normally regular GPS will do better than 10 yards, 10 meters. I mean, that's its worst case spec, but normally it does more like 3 meters.
I've seen 3 meters before, but I'm not seeing it right now, so I'm not sure what's going on. So, I'm not happy with it.
No,
because I just put it outside and just let it sit for a half hour and plotted the GPS, and it was going all over the place. So.
Yeah, but 10 meters is more than you would usually see.
Yeah, I was thinking 5 would be like worst case. But
yeah, most GPSs will support some kind of like augmentation. If there's no differential augmentation, then you could see that worst case. But like, for example, your cell phone will and most GPSs will look at some so there are other signals that come down from satellites that can give you some wide area augmentation that sort of like come for free with GPS.
So maybe just running it in U-blocks, but maybe just running it in the most primitive mode or something.
Yeah, that's what I'm wondering. Is you should see. I would think you should see better than that. Let's see. Someone else said they had something to share.
Harold.
Yeah.
Harold. Yeah.
Yeah.
So a few things. One, you're going to see some annoyance from me because after I've got to kick off some resin. When I do that, I'm going to sit down and I have a couple of breast cancer awareness charity pins I'm about to throw up on eBay for an auction, 100% going to Susan G. Komen. And so I'm just letting you know I'm gonna let people know, and I might be too noisy, and if I get way too noisy, I apologize now. I'm gonna hit all my socials that I can, that kind of thing, and whatever will be on these things, and hopefully we'll raise some money for doing that. Saying all that, more on the thing of something along the charity thing, but more of the maker space of things. I'm going to drop a couple of links in the channel. Well, I had a couple of links to drop in the channel a second ago. The first link is all the wonderful models that we can print. I've got a couple I will show here real fast. And I know several of you helped me last year. This is the same thing again with the Loyal Moses Christmas print drive. And that's the printables link, the first one. The second one is a link to the actual thing that's going on. And I don't currently have any extra filament to pass around. If I do, I will be bugging people to pass it around. And just so you know, the models are all kit cards this year. So they're going to put things together. And for instance, a little robot. In fact, this is a heavy robot. This is like almost 400 grams. I can only make 2 of these per spool. And I've got a girl, she's got ribbons, and I got a boy that doesn't have the ribbons on it. And I've had a person wanted me to print a big pen, and she already donated 11 spools, and I'm down to 2 spools that I haven't cracked open yet. Or sorry, 3 spools not cracked open yet. And the other thing is this thing here, the big old jet airliner, complete with jet engines. And this is rainbow filament. They have a painted model, but it's been having a hard time with the engines not making it because they knock themselves over and they don't adhere well. We have motorcycles. You see all the things in the link there. We've got motorcycles. We've got spaceships with aliens and things that look like a fence that you can make an Area 51 sort of thing or make a tower out of it. You've got tic-tac-toe and checkers and not checkers, just tic-tac-toe, and a whole bunch of different models like that are a lot of fun.
Hey, Harold, do you want to explain for the group what the Loyal Moses print thing is all about? Because a lot of people probably don't know it.
Okay, so Loyal Moses is arguably the largest 3D print community channel on Twitch. There's a couple of other people that are very large too that actually print. I don't know. I can't remember the last time I actually seen him print something on the thing, but that's how he gets it. It gives away a bunch of filament and everything. But he's very giving, him and his wife. And every I think this is the 6th or 7th time. I think it gets bigger every year. Polymaker, just give you some numbers. Polymaker is one of his sponsors. They donated over $250,000 in filament last year. I received almost 28 rolls, 28 spools, one of which Paul got, and Paul printed us some toys. And the idea is these toys, are they going to change anybody's life? Who knows? The idea, though, is they put a smile on a kid's face, at least for a little while, and they're given completely free. And last year, Paul and some of the people related coming through me sent in over 650 toys out of the 83,000 toys that were printed and shipped up and shipped out to kids around the world, not just in the United States, but around the world. And they got the kids, the parents have a way to fill out a form to say, my kid likes these things and that kind of stuff. This year is science, it's discovery and exploration is the theme, and everything's a kit card. So every time you get this thing, you got to break them apart and put them together, and then you can play with them, is the idea of it. and it's a charity. There's several 3D printing charities out there. Loyal happens to be the largest one I know about, and the one that I feel more engaged with. I tried to do the Toys for Tots with IC3D and their filament, and I didn't feel very engaged with those folks. I tried to, but for whatever reason, I didn't get the engagement I was looking for. And if you look around, I mean, those are just two, Loyal, the IC3Ds, and there'll be a couple of more show up, or Toys for Tots. There'll be a couple more show up there doing these toy drives too. So if you have a 3D printer, I would encourage you to print out a toy and send it in, or go buy a spool. You know, go like for instance the robot ones that we have here. You can only get really 2 of those robots out of a spool, so they're a little high dollar to print. I'm printing a Buck Rogers looking spaceship thing over here, and I can get 9 of those out of a spool. For $20 a spool, and I get 9 of them. That's a pretty good thing. Each kid will get a toy, a note, and a surprise, and a present in a box, and they all fit into a 3D printed box. I'm unsure on some of the things because they haven't been revealed to me, but we're supposed to have a form we can fill out where you should receive a roll of filament. Loyal himself will be. It said he's about to scatterbrained as all get out because he's doing 50 million things, but he should be doing a tour. Last year he did a tour. He came through Dallas Fort Worth. We met in the Micro Center parking lot at 7 p.m. on a Sunday night. He gave away a pallet's worth of filament, which I got 28 of. In fact, I picked up 20 of them. I go, I'm good. And he's like, man, there's more on the ground here. Pick up some more. Take some more, please. And so I managed to coordinate not just myself, but people like Paul and some other friends. The deal was, if I give you a spool of filament, you give me a plate of toys. And in this case, it's going to be 1 toy on the thing because the toys are larger in size. And that seemed to work out pretty good. And the rest of them, do whatever you want to do with it. And I don't know, Paul, you had a good time printing these things. You come home, you set it off, and you come back, and you got this plate full of stuff where nothing was there before. That's kind of fun, right?
Yeah, and it's for Christmas, right? It's
for Christmas.
Toys for Christmas.
And it's for Toys for Christmas. And are you going to make? Are you going to change a kid's life? Well, I don't know, but you're certainly going to put a smile on their face at least for a little while. And there's nothing wrong with that.
Harold, you know who you want to talk to here is Jesse on the call. Jesse is part of the UTD Makerspace, and they got this amazing array of 3D printers.
I know Matt who helped run that place over there, and yeah, you got a bunch of printers over there. So Jesse, if you want to join in on this, I don't know if you know who Loyal Moses is, but let me see if I can do a quick look up here. I'll send you a switch, or no, I've already sent you the link. That link in there, the one that says what's a toy drive, it's got all his communications, all the Discord, his Twitch channel, the whole works. And Loyal gives away tons of filament every show he does. And that's one way to get filament. Another way to get filament is meet him somewhere whenever he does these tours. And then another way to get, I mean, this is all free stuff, right? And another one to get filament is jump on the Polymaker Discord and get on there. They give away tons of filament too. And I've got a couple other Twitch streamers, Pezliz and Zombie Hedgehog and Bearded Printer and K2 Kevin, and those people give away stuff too. So there's plenty of ways to get free filament. But Jesse, if you want to coordinate UTD, I think if you contact Loyal and Mrs. LM, if you will contact them through their contact form and let them know that, hey, I've got 20 printers or however many printers, and we want to print a lot. How can we get thing? And I can't tell you what they're going to do. I can tell you what they did last year. The Las Vegas Makerspace got a pallet of filament shipped to them from Polymaker to print toys. So, and do they expect all of that to go to toys? Well, they would like it to, but they're realistic, right? They would like a good effort and be able to throw out a number of toys. And this year the count's going to be lower, but I think as far as number of toys but I think that number of kids serviced is going to be higher because each toy takes a lot more than, you know, it used to be I could print a trash can with a lid on it and that counted as one toy or two toys depending on how you were counting. Now I'm printing a whole, effectively a cardboard box the size of a printer, a 3D print spool, a filament, and that's one toy. So I mean that there's a difference in scale, but they had to do it differently because of a bunch of stuff. And he has a lot of fun, by the way. So if you get one of these things, you send it into Loyal Moses. They routinely have openings. So if you want to hear your name yelled out to 200, 250 people, that's usually what's on this stream. They're opening up. They're giving you a shout out to your model. You put a little note in there to them, say, hey, you know, I printed it on this with this kind of filament, and I hope I have a good day. You know, I hope somebody has a good day, and yada, yada, yada. Along those things where they're having a good feeling on it. It's all about being a faucet, not a drain. You know, giving a little bit more than you're taking in, and that's how it kind of works. I could rattle on about more and more and more about the same how much I'm happy with being in it, but I think the best deal is if you go check out the two links I said. One link is a printables where all the models are going to be the official models that you can print are there, and the other link is going to be a description of the program, the print settings they're expecting. For instance, if you're printing with silks, which I had a friend of mine send me a spool of silk, and it's gorgeous. But the problem with the spool of silk is the silk tends to be a little weaker. So you got to up the wall count and you got to up the infill count to compensate for that, and the top and bottom shell count. And once you do that, you lose a little bit. But it comes out a gorgeous toy, right? So it gives you all that information.
So this is using PLA, correct?
You can use anything that you want. You want PLA? Cool.
But I'm just saying the PLA is biodegradable somewhat. So it's a sort of an environmental friendly toy versus a plastic one.
Okay. So say it again. I'm sorry.
So PLA is somewhat biodegradable, whereas like a plastic toy that you don't want to get out of the store, they don't biodegrade, and kids only use them for a couple of years and throw them in the trash. So it's actually more friendly, environmentally friendly to have PLA toys.
If the only thing they say in the specs is they don't want you to do any carbon fiber or glass fiber embedded filaments. I mean, for the obvious reason, kids could be chewing on this thing, and we don't want them chewing fibers, right? The other thing is you can use ABS, PETG, PLA, the different forms of PLA, the HTPLA. You can use one of the newer filaments that Polymaker has, which I've started playing with. It's called COPE. It's a copolyester, and it's got a higher glass temperature. It's got a 90° C glass temperature, so it actually may survive. It will survive better. Will it actually survive in your car in Texas in July? I don't know. The jury's still out. I haven't tried that yet.
It will. We use COPA all the time.
Do you? Thanks,
Polymaker. Yeah.
Thanks, Kareem.
That's our standard film.
Well, luckily Christmas is in January and December, so
yeah,
PLA will work.
So also another shout out. Kareem, am I going to see you next Tuesday night, like in person or close to in person?
Yeah, I kind of have to be there, don't I?
Yeah, kind of.
If you're going to be there, I'll be there.
I'll be there. He's going to be presenting to the Hackster group in improving next Tuesday night. And so, and I'm glad to know that
I need to see if I can get up there before then, just to verify that the network is all good for my robot.
Okay, so I will tell you this, since it's fortuitous that I was able to get on. I've been joining here lately, and I've been nobody here because I've been joining so late. You guys are gone.
Mm-hmm.
At least I think that's what it is, or maybe you just don't like me. I don't know. I'll leave that alone.
We love you, Harold.
I'll leave that alone. Kareem, I am there Monday, Tuesday, and Wednesday. Almost 100% guaranteed, especially next week for sure. All day long. So come by whenever you like. You're welcome to come by Monday if you want. You're welcome to come by as early as you want on Tuesday and do whatever you need to do.
Okay.
And work through that. Yeah.
You're there during the day?
Yeah.
Okay.
Yeah, I am there on site, banging on a keyboard, you know, and hopefully turning out value for my client.
They got a public Wi-Fi that's not.
Yep, they have a guest Wi-Fi just for people like you.
All right, cool.
I don't know, that didn't come out too good. But anyway.
But do they have AP isolation? They probably have AP isolation turned on, which tends to screw up robots.
Well, no, what it is there's a secured network. There's a secured wireless network and a open guest network. And you connect up to the guest network all you want.
Yeah, but AP isolation, is a feature that you find. Access point isolation is a feature that you find on a lot of public E.
I don't believe we're doing that. I do not believe we're doing that. We may be, but I don't know one way or the other, Paul.
Oh, this is why I want to test.
Right, and that might be what was going on at the makerspace, Kareem.
Yeah, because it was fine once I went back on my hotspot. Just a little
right,
slow.
Right. You effectively have to bring your own hotspot.
So, all right. But anyway, there's my goings on, and so expect to see some noise about. I got 2 charity things I'm in the middle of. One's the breast cancer awareness thing. I'm going to have 2 pins up there up for auction. The other thing is I'm turning a couple of in fact, that's what I got to start there. The resin on Christmas ornaments that I'm going to be sending off to one of the people that I'm hanging out with. It's called Turner's Warehouse, but it's a outfit out of Tucson that are having a Christmas a St. Jude auction, and we're all sending in Christmas ornaments for that to auction off. Some of those things are really, I've seen some of them come through, and I'm like, I don't even. And it's a contest too, and I'm like, well, it's a good thing I'm not planning on winning a contest, but I'm still going to enter it in, and hopefully I'll get a little money for St. Jude for these people. You know, because I've seen some of the stuff come through, and I'm like, oh, that's just simply amazing. What are you cats doing with wood and turning it on there and all this crazy stuff? I think I can light one up, put my ergoblades in it, and then somebody I got one that flashes, and then they did an unboxing the other day, and it's got this one that looks like a wood on top of wood with a LED band that goes all the way around that oscillates and does all this stuff when you turn the top of it, and it's like this tall, and it's got this spiky thing going on. I'm like, oh, no, okay, I gotta like the place. Okay, we'll just roll with that. We'll see what, you know. It's still for a good cause and that kind of thing. If you guys want to hear about that too, as soon as I know where all that stuff is, I'm going to tell you anyway. But it's going to be, but that won't be until December sometime. Yes.
All right.
That's all the wacky stuff I got going on at the moment.
You always got
not very much robot biz, but
anyone else got anything for open mic? We're sort of starting to lose members here, or is it time we called it a night?
Yeah, I usually run people out. They close the doors on me. I know that kind of works.
All right. Good night, guys. See you next
night,
Tuesday.
Guys.
Hey, Doug, I think it's just you and me at the moment. You interested in grabbing some of that salmon here sometime? You're on mute. You're muted.
What day?
I'm pretty open.
Well, we could do it tomorrow. Does that sound good?
Let me just check my calendar. Hang on. Yeah. Yeah. Today's Tuesday. Live.
Not tomorrow?
Tomorrow's not gonna work. I could do Thursday.
Yeah, Thursday?
Yep.
Okay. Let me get it in here so I won't miss it. My brain doesn't remember things too well anymore, if you know what I mean.
Yep.
Okay.
And I'll invite. I'll ask Mark if he wants to come too.
Sounds great.
All right. Well, I forgot what time we usually meet. About noon, right?
Yeah, 11:30, noon, whatever you like.
Okay. I'll shoot out a mail or a message to Mark and see if he wants to join us, and see we'll call it 11:30, unless I get back with you to change the time based on Mark's availability.
Okay. So, all right. So 11:30 Wednesday.
On Thursday.
Thursday. Yep.
Thursday the 16th.
I'm gonna get that. Okay. Okay.
All righty.
Got it. All right then. We'll see you then. Yeah. Okay. Bye-bye.
Bye.